Good morning. Welcome to short video series by SparkHadoop. About SparkHadoop, we are a team of freelance professionals from different companies such as DataDotz, Cognizant, and also from technical communities such as Chennai Hadoop user group. We are further to say that we are all certified on a lot of technologies such as Apache Spark, Cassandra, Apache Hadoop, even on cloud computing, and further to say we are also certified on a lot of BI technologies such as Tableau. What we do is all about training. So the most predominant courses of our training are two. One, Big Data Expertise Level 1 and Level 2. In Level 1, we go deep dive into Apache Hadoop ecosystem as well as Apache Solar, and also we give you a quick start to Apache Spark. In Level 2, we concentrate on other important technologies such as Apache Spark, NoSQL such as Cassandra, and MongoDB. We also give a quick start to Apache Storm and differences between Spark streaming and Apache Spark. And we do dive into Apache Kafka, which is very important nowadays for the streaming inputs. We do refresh course on Scala as well as Linux for the newbies. We help with the certificate assistance for most of the technology, including Spark, Cloudera Hadoop, Hortonworks, and other predominant certifications in big data and cloud. The three modes of training that we provide are instructor-led classroom training in our office at Chennai, Tamil Nadu, India. We do provide online training, and in the near future, we plan to provide self-paced training. Let's get back to our topic of today, Apache Hive. Before we jump on into Apache Hive, let us look at the core Hadoop components, that is HDFS and MapReduce. HDFS, Hadoop Distributed File System, provides distributed storage, and MapReduce gives you distributed computation. Let's first take example HDFS. HDFS, as I said earlier, it provides distributed storage, which is internally nothing but files and directories. Let us take for an example, I do have a folder or directory in HDFS, a folder by name patient, and it contains data of almost 10 terabyte, and each line is a record in the file, and in the line all the data are separated by comma separated. And as a developer, I do want to analyze the data. For example, count of patients, which means count of the records. If I want to do it, I have to either do it via programmatically. I could use Java, on which Hadoop as well as MapReduce, the HDFS and MapReduce has been written, or I could use other languages which is supported by MapReduce such as Python and C++, or if I use Microsoft Hadoop version that has the inside, I could still use C# and other scripting languages. So for example, let's take Java. I'll write set of classes, I'll compile them to jar, then I submit the jar to MapReduce, which in turn run across multiple machines as part of the computing framework, and on the data that is stored in HDFS again across the machines. Now let us take an example of a BI developer or a SQL DBA guy. If he wants to do the same thing, count of the records, simple, he wants to give back the management number of records in a particular table, he cannot do it because he has to know Java, he has to know what is MapReduce, he has to know what is HDFS. It becomes very difficult for him to do a simple task, count of the rows in a particular data, that is patient data. So that has become very difficult. To address the problem, in earlier days, Facebook came up with some new component called Apache Hive, an abstraction component which sits on MapReduce. So as a developer, I give a HiveQL. When I say HiveQL, Hive query language, which is nothing but a subset of SQL 92. Reason it's being subset, it doesn't provide all the SQL 92 commands In early days, the update, delete, all those commands were not there, but nowadays it has been implemented in HiveQL. But still we say subset of SQL 92 because lot to implement as part of the standards. So as I give the HiveQL command, the Hive, it will internally convert into MapReduce and runs across the machines and gives back the data again. Okay, let's take an example. I take select, count from table 01 and it will run across. Wait a second here. I could see here table T01, but what I had here was a patient directory. Where is the mapping? How does it know I'm talking about patient directory? How does it know each line is a record or each column is separated by a comma, that is comma separated values? How does it know? So for that we have to create a mapping. And this mapping is stored in Hive. Hive internally stores in it an embedded database by default. So by default, it comes with Derby, which is an internal embedded database for Hive. So this mapping gets stored across where it says T01 table is pointed to directory called patient. Each line is each record is nothing but a line, or the columns are separated by CSV, and which first column is something, patient ID, patient name, all those things. This is a mapping I'm talking about. This mapping gets stored in embedded database, or in later or in production scenario we could migrate to MySQL or Postgres, an external database, but point the Hive to the external database where you store just the mapping. We are not storing the data, which is huge. The data still lies in an SDFS directory called patient. Under that, all the files are your data. So using this mapping, it identifies, okay, T01 is nothing but patient. It creates a MapReduce jar, basically MapReduce job or MapReduce application when you talk about Hadoop 2. That gets submitted to MapReduce, and MapReduce runs across the storage and gets back the data. So simple. What you have to know? We need to know the table mapping, which is basically a table, and we need to know HiveQL, which is a subset of SQL 92. So as we talked earlier, this RDBMS does not store data. Instead, it stores the mapping data, which is nothing but Hive tables. Basically, when you say table, that's a mapping data which is mapped to a directory in SDFS. So this has made possible for several tools to communicate with the Hadoop. Example, Tableau. Tableau is a beautiful tool to visualize all your data, and at the end of visualization you get a beautiful dashboard to tell the user stories to your executives. So this is made possible. I do not worry about what is Hive at all. What I need is all about a database and a table. Here table is nothing but a mapping, and database nothing collection of tables. So here we could have something, a collection of tables, which is in our SQL scenario we could say is a database. So using that, if we have Hive driver installed here, the Hive JDBC driver or ODBC driver get installed here, it can automatically converts your visualization into Hive queries. Hive query run on the Hive table and makes very possible. So that's not the end. Let's go back to the next one. You could see here Hive internally, that's what we saw earlier. Hive converts in MapReduce and over distributed storage. When I said distributed, we talked about SDFS. It can also run on NoSQLs, not only SQLs such as HBase or Cassandra or any other such as file systems like S3. S3 is Amazon's distributed file system by default. So we could even run on that. So later, to improve the performance of MapReduce, they came up with a new framework, especially for Hive, all these abstraction framework. There's something called Tez. Tez is a Hindi word for speed. So you can use any one of the backends Another backend is Apache Spark. Apache Spark is much faster than MapReduce with respect to batch computing or interactive analytics, all those things. So Hive can either use any one of the backends for processing and distributed storage. Till now, we have been talking about Apache Hive. Apache Hive is nothing but an abstraction on top of either one of these three. And it only works on structured data. Whatever queries that you give, it gets converted into MapReduce jobs or Thais application or Spark application. It's similar to SQL. It doesn't provide all the commands. Those are in development stage. Soon we'll be getting all of them compliant to SQL 92. Installation is very simple. I have to go into hive.apache.org, download the latest version and point it to Hadoop, and it will start working with Hive with MapReduce, Hive using MapReduce and Hadoop. If you want Spark, you have to download Spark and point Hive to Spark, then plus Hadoop, which is basically SDFS. To start it, bin/hive, it starts a CLI. CLI is nothing but command line interface, something SQL similar to your SQL command line. Where shall I install it? When you talk about Hadoop, Hadoop is a distributed installation. You may need to have at least 1+ nodes to have a distributed kind of installation. So you could look at here, Hive can be installed on master node or any of the node. Predominantly, we always prefer to install it over master node. Or you could install outside your Hadoop on a client node. That's we call it as edge nodes. Hive execution modes, we talked about command line, which is nothing but bin/hive. In older version, we do have a Hive server by which we can use JDBC or ODBC or Thrift. Thrift is a protocol for communication, came from Facebook. In later version, we have a Hive server 2, which also provides a client server concepts, and they have a client which is called Beeline, which provides a CLI, which in turn can connect to Hive server. That's why CLI, the older version, getting deprecated in the newer versions. And HCatalog is nothing but a catalog of tables to be used by other services, which we'll be talking about later. Other frameworks. When I say other services, we are talking about other frameworks. Let us look at some of the HiveQL commands. So first command, we are going to look at the creating a table, nothing but creating a mapping. Let's look at the file. We talked about patient file. This is a patient file example where each line is a record. I could see 7 records here. First record, if you look at, there are 5 fields. First field, patient ID, patient name, drug, gender, what is the total amount. So you could look at here, I'm creating a table patient, which is nothing but a mapping again in Hive. Create table patient, PID, integer, data type, patient name, string, drug, string, gender, string, total amount, integer, that's a data type. Next, if you look at here, I given row format delimited. When I say every row is delimited, that is, the fields are terminated by comma. You could see here, every field is delimited by comma. It is stored as a text file, which I mean is that every line is a record to me and the fields are terminated by comma separated. Wait a minute here. We talked about T01, which is getting mapped to a directory called patient table. So here T01, I mean patient table, getting mapped to a patient directory. But here in the command, I could not see any directory. By default, when you don't specify it, it is creating a directory called patient directory under this folders /user /hive /warehouse /patient directory. So this patient table is mapped to this directory. When you hit show tables, it will show there is a table called patient in the Hive mappings. We have created a table. How do I load the data? Here we are talking about directory called patient. So /user /hive, which is a default path. We could change that, not a problem. /warehouse /patient. This is directory. I need to load files into the directory, right? There is two ways. For example, if you have data in HDFS, for example, this is a file in HDFS, I could in turn move this file into this directory. That is nothing but load data, which is internally HDFS shell command if you use mv move command. Or if I have it in the local machine where the Hive is running, I want to copy that into the Hadoop, I could use load data local in path. When I say local, it's a local to the Hive where it is running across. It internally runs a copy from local command. So it copies into patient directory. We have created a table. We loaded some data. Now we can run across some queries. So select count of, select sum of, and select star from where drug in. You can use a in clause. So if you look at the last one, select star from, it does not run MapReduce. Reason being, here we are not doing any analysis. It's just a file read. While reading it, it'll identify every line is a record, comma. So I mean the line is the columns are separated by comma. It does not run as a MapReduce. It's just a file read from Hadoop. Let us look at architecture. We talked about CLI. We talked about Hive server, which is internally JDBC or ODBC. You can connect across. So all your BI tools comes here. This is about Hive server 1 architecture, where all your BI tools you use ODBC, which in turn connect to the Hive server. The driver is the one which passes the query and creates the MapReduce jar. While creating it, it needs a mapping, and the mapping, as I said earlier, it gets stored in a DB. It can be by default Derby, which is embedded, or you could use your own MySQL or Postgre or Oracle or something else. So the metastore is a component which internally stores in the DB, and you could see file system. We talked about select star from, where it does not run MapReduce. It's just a file read. File system APIs are nothing but HDFS API which connects to Hadoop and read the file and gives the data back again. Job client is the one which submits the jar which is generated by driver to the Hadoop cluster and gets the data back again. So earlier we talked about Metastore. Metastore is the one which creates a mapping and stores in database. We could use this Metastore for different components such as Impala, Hive, Pig, MapReduce, or Spark. So Hive Metastore, we can start it as a separate Metastore. It can be used by Impala. Impala is again MPP from Cloudera, and Pig can also use the same Metastore through a component called HCatalog, and MapReduce same HCatalog. And Spark can reuse this remote Metastore in its application. Whatever tables that you have created in Hive, it can be used by any of the things. So for example, I created a table called patient in Metastore. This metadata or mapping can be used by in Spark. In Spark, I can just give the query as select count from patient and just point the Spark to this Metastore. You create one mapping and reuse in different technologies or different frameworks. With this, we have come to the end of the short video on Apache Hive by SparkHadoop. Thank you.